Today we're going to talk about rigid motions. This module basically describes how the robotics device going to move in three-dimensional space. And when we are dealing with three-dimensional movement, we cannot describe everything in the regular x, y, and z coordinate. The reason is because we are putting our sensors on individual joints. So when we describe the positions, we are based on the sensors. So in order to understand what's going on of the movement at a specific location, we would need to find a way to transform from one coordinate to the other coordinate. And based on different joint, the coordinate is going to be a little bit different. So we're going to deal with the tools that use for robotic device. But before we start, we're going to talk about traditional kinematics and how it is represented in vector representation. So when we deal with traditional kinematics, normally we are describing the system in x and y coordinate, of course. And let's say we have 2 points, A and B. So this one is our origin. When we describe the vector or position vector of RA, we are dealing with position RA equals to RA xi plus RA yj. And if you try to describe the position from original to the position of B, certainly we can say this one is RB, and you can use the traditional way we define over here. But sometimes when we are dealing with the position at point B, we would like to describe that based on the observation at point A. So if you are standing over here and you try to find out what's going on over here, that is going to give you another vector, which is RB over A. RB over A is measured based on the observation at point A. So when we say RB, we would need to define that in two different kind of representation. The first one is, of course, where the observer is located. And the other one is going to be RB over A. So in this case, we are talking about RA xi plus RA yj. That is original position of point A. And the other part we would need to know is, now this one, RB over A xi plus RB over A yj. So when we are combine those two vectors, we can describe the vector of RB xi plus RB yj. So this is how we describe the position. If you want to describe velocity, it's similar. We have VB equals to VA plus VB over A. That's given. But when we are dealing with those kind of things, the VA is moving. The VB, if this is a rigid body, which means this one is going to rotate about point A because it's rigid body. The only thing this one can move is going to rotate. So when we are dealing with this thing, VA remains the same because we need to know the information of velocity at point A. But when we are dealing with point B, it is going to be the angular velocity rotated about point A cross product, the moment, the distance between B and A. So it is going to be something like this. So if we can find out how to calculate the information over here, certainly we can know how to find out the velocity at point B. That is something we're going to deal with for using traditional kinematics. However, there is a drawback of doing this thing. Just like what we said, when we are dealing with robotic devices, the sensor is going to be located, and the sensor might be located. If you have a third arm over here, you might have another sensor located over here. So when this one starts to rotate, we are no longer using regular xy coordinate that we used to have at origin. Instead of having that, you might have another coordinate like this. You might have another one over here like this. So when we are dealing with those kind of stuff, it is important that we know how to convert from the regular x, y coordinates. Let's say this one is 00, and we need to deal with this one over here. This is my xa, ya. Let's name this one as my oa. And we might need to deal with another one over here. This is going to be my xb and yb. So this coordinate, this frame over here, we call it OB. So how are we going to convert from this coordinate to this coordinate, from this coordinate to this coordinate? That is something we're going to talk about in this specific module. So let's get started. So this is an example that you can find in your textbook. So we have an x, y coordinates over here. Let's name this one x0 and y0. And we try to describe the position P over here. But meanwhile, we have another sensor located at this position over here. And we use another coordinate x1 and y1 along those two directions. So in order to find out what's going on over here, you can say, okay, I measure from a sensor over here and over here. The position is 5 and 6. Which is of course correct. But can you say the position is always 5 and 6 like this one? Of course you can, because it depending on how you're going to have your where you're going to start to do your measurement. So it's going to be a little bit different. So instead of using x0 and y0 coordinate, I'm using x1 and y1. So similarly, we're going to define xy position and x position and y position. And in this case, we're going to have this one as 4.2. This one over here is 2.8. And we know this is my positive direction and this is my negative direction. So we can define this position over here as 5, 6 observed from x0, y0. We can also describe this position as P1, that is going to be negative 2.8, 4.2, based on the observation we have over here. So based on how you're going to describe your, based on which coordinate you're going to use to describe the points, you might have different numbers out of those two systems. So when we are dealing with this one, you might notice that the notation over here is going to be a little bit different. Though we are using P, the position, we are interested. The P naught over here is, the 0 over here is defined as the reference frame. Of our interest. Okay, so if you are using P1, it means that you are observing this point from coordinate x1 and y1. So we're going to use those kind of relationship to describe what's going on in the next slide. So again, if we are having something like this, we have two systems. Instead of describing the position P, sometimes we might also need to know what is the coordinate, the origin of individual coordinates going to be located by using another coordinate system. So when we are dealing with something like this, let me change my my color again. So when we are having something like this, keep in mind this one over here is the reference frame. and this one over here is the number of frame, which means, okay, if I have my O over here, this is my O1, this is my origin of the 0th frame, and this is the origin of the first frame. So if you draw a line over here, and if you forget about the coordinate you describe over here, this one over here is simply a position in two-dimensional plane. The distance over here, we can use we can use the ruler to do the measurement, and this one is going to be 10. And if we do something like this, and the distance over here is going to be 5. It means that if we try to find the position of frame 1 viewed from frame 0, we are describing the position. Of course, this is my position, which is 1, and I viewed from 0. Then I'm going to have 10 and 5 in this case. So similarly, let me change my color again, so it might be easier for you to understand what I'm doing over here. So this time, if I want to use this one as my reference point, and I actually measure that based on this one over here. So I have this coordinate 3.5, and this one over here, that is 10.6. So if we can rotate this coordinate to the regular XY shape we used to have, this one over here, we try to measure the O0, the position of the origin over here, and we are trying to view from coordinate 1. Then this time we are going to have negative 10.6, and the y coordinate is going to be 3.5. So this is how we describe the system. Of course, if you say, okay, how about if I viewed the coordinate origin based on their own frame? What are the number is going to look like? Okay, of course, that would be straightforward. If you try to measure the origin based on the frame of 0, certainly it's going to be 0 and 0, because we try to measure the position of origin in the two-dimensional frame of x0 and y0. So it's going to be at 0 and 0. If you try to do the same thing to measure the position of origin at 1 from the frame of 1, it is going to be the same result, which is going to be 0 and 0. Okay, that is going to be our system coordinates. So let's move to another slide. So this is based on position, but when we dealing with a position, it is relative information. There are few things we are dealing with magnitude. For instance, if you are we are talking about movement. So if you say, okay, I move 5 meters from position A to position B, and you measure that in x0, y0 coordinate, it is moving for 5 meters. If you say, okay, I use another sensor located in using x1 and y1 coordinate, and I try to measure the movement is going to be the same. It won't change its magnitude based on different coordinate. When we say it's moving, it has been moved for 5 meters, you can get the same result in terms of x0, x0, y0 coordinate, and it will be the same in x1, y1 coordinate. Same for velocity and acceleration. Because we are talking about magnitude. They must be the same, regardless to the reference. Right. What does that mean? So let's say you got the velocity over here measured from coordinate x0, y0. And we say this one over here, v1 measured from frame 0. And in x direction, we know it's 5 meters per second. In y direction, it's 6 meters per second. Okay, so that is something we get. If you get the velocity, that is going to be 5 squared plus 6 squared, and the result is going to be 25 plus 36. That is going to give us square root of 61 meters per second. Straightforward, right? Because this is something we deal with in kinematics and in physics many times. So if we are measuring the velocity in the coordinate x1 and y1, we might get a little bit different result. Why? Because along here, the xy direction is moving in this direction. Y is moving in this direction. If we are dealing with the coordinate system x1, y1, what happened? We are actually dealing with the velocity along x1 and y1. So it's actually moving in this direction and in this direction. It is not going to be the same along this direction and this direction. So when you get another sensor, measure the velocity of position of object 1 from coordinate 1. You might get a result like this. That's totally feasible because, again, depending on which frame you're talking about or you're measuring the movement, the velocity is going to have different magnitude along individual directions. However, since we're talking about velocity, the magnitude of the velocity must be identical to the number you measure from the other frame. It means that v1 should be 7.77 squared plus 0.8 squared. And take the square root of this one. It must be the same number. So when you are dealing with velocity, movement, acceleration, as long as they are not vector related, the magnitude must be the same. That is something you need to keep in mind all the time. You cannot say, okay, I have my velocity in one frame. It's going to be different velocity in another frame. It's not physically correct because you might have different velocity along the individual axis, but the magnitude must be identical. So the next thing we're going to talk about is, okay, so we know the concept. What are we going to do when we have different coordinate system? Okay, so let's talk about rotation a little bit. So if we say, okay, I got x1 coordinate over here, and x0, y0 over here, and I get another x1 and y1 over here. And based on this configuration, it is straightforward. If I want to describe the position, if you got a unit vector, along x1 direction, what do we have? Let's say this is 1. Then we do, no, let's use this as 1. So we are interested in when this vector projected onto x0 and y0 coordinate, what are they going to look like? Well, this is just some kind of cosine size thing that you can put into a matrix. So if you try to describe the position, which is 1 in x0 description, it is simply cosine theta in x direction, sine theta in y direction. Same over here. If you try to describe unit vector along y1 direction using the frame x0 and y0, then over here, this is going to be sine theta, because when this is theta over here, theta must be over here. And over here, this is going to be my cosine theta. Okay, but keep in mind, when you are using x0 and y0 coordinate to describe this, the sine theta over here is along the negative direction, which means your y1 viewed from 0's coordinate over here, it is going to be negative sine theta, and the y direction is going to be cosine theta. So if you try to convert, if you try to describe the coordinate system of the first frame viewed from 0's frame, you are combine those two vectors together, synthesize that as a matrix. So this one over here is going to be my x10, and this one over here is going to be my y10. So this is something we're going to use from now on and convert the coordinate from one frame to another frame.